Well, welcome to class number 6 of our series on Creation Science 101. We're going to take a quiz over what we've covered so far from last week, and then we'll go on to some new material dealing with the age of the Earth. Let's deal with comets now. Comets are flying around through the solar system. I don't know the percentages, but they estimate that a certain percentage are made of snow and ice packed. Some are made of rock. Some are made of iron. Some are made of nickel. Some are combinations of all of the above. They can tell what they are by what color they burn, if they burn into the atmosphere. Just flying around, though, as they get closer to the sun, the solar wind begins to blow a tail off. It begins to melt pieces off, and the tail flying behind the comet is actually fragments of cometary material, which means they're constantly losing some of what they have. Estimates are that a comet can last about 10,000 years. Now, there are two kinds of comets. They're called short-period comets. Those are ones that come around, and they can predict when they're going to come back. Halley's Comet, for instance, is probably one of the most famous short-period comet. So there'll be a test or quiz question. What two types of comets are there? Short-period are, they come around once, come around again, in some are 3 or 4 years they come around. Some are 76 years, like Halley's Comet. Some are longer than that. The other comets are called long-period comets, where they just come by once, and we don't know where they came from or where they're going. Just came by once. Okay? You can't predict those, of course. But short-period comets have a life expectancy of less than 10,000 years. They should have destroyed themselves by then. The fragments of these comets that are breaking apart, sometimes the Earth runs through the path of these comets, because the Earth is going around the sun at 66,000 miles an hour. If you're driving your car at 66,000 miles an hour through a cloud of debris, of dust, in a sandstorm, it's going to create all sorts of problems. And the Earth running through this trail of debris in space, it's the same as if it was hitting us at 66,000 miles an hour. We're hitting it. And our atmosphere is 100 to 200 miles thick. It burns up 99.999% of all the debris out there. It acts as a cushion. And so at that speed, the air friction gets up so hot, so fast, it burns them, turns them to ash, and they disintegrate. About 5 fragments a day get all the way through the atmosphere and strike the Earth. Sometimes pretty good-sized ones. When they hit the Earth, they can do a lot of damage. You were with me, you saw the Barringer crater in Arizona. Gigantic hole in the ground. Something hit and blew this massive hole in the ground. They say the bottom of the hole is big enough that you could play 20 football games simultaneously. On the sides of this crater, you could hold, I think they said 2 million spectators if you set it up with bleachers. It's about, I think, 7/10 of a mile across, if I recall. It's named Barringer because some guy named Barringer bought it. He bought the property. It's the middle of no place, Arizona. He wouldn't want the property for anything else. But he knew that many comets are made of nickel. Nickel is a relatively expensive metal. It's used, they mix nickel in with iron to make gun barrels, because when it explodes, when you fire the rifle or the cannon, it's going to swell and come back. It allows the metal to swell and not stretch. If you just used iron, it would swell, and every time you shoot it, it gets a little bigger, and pretty soon your bullet's flopping around in there, and you don't want that for sure. So the nickel is used to give the elasticity, but nickel is a pretty rare element, and the nickel is what is highly, comets contain a high degree of nickel. So Barringer bought this property. He thought, you know, if a comet hit here, maybe it's buried down there someplace. I'm going to dig it up. I'm going to mine it. I have a nickel mine and be able to sell this metal. So they found these fragments of nickel all over the fields. As it was coming in, apparently it was burning, and pieces are flying off the back of the comet, and then they would cool down and drip. So they find pretty good chunks of nickel all over this field, you know, within a few miles of the crater. He drilled several holes in the bottom looking for the meteor, found nothing, went broke. He had enough money for one more hole, and he was out there with his pistol shooting in the mud, studying, you know, how deep did that thing go anyway, you know, checking the size of a bullet and the speed compared to how hard is the mud. And he noticed a gun accidentally discharged, is the story I heard, at an angle. So the bullet went off at an angle, hit the mud, and made a round hole. He thought, man, if you hit at an angle, it's going to make an oval-shaped hole. No, it made a round hole. He said, wait a minute. Maybe the comet hit at an angle, still made a round hole, But here I've been digging down in the middle of the hole for this comet. It might be buried outside the hole. So he did a bunch of shooting into the mud to see, you know, what it would do as far as, and you notice one side comes up higher than the other of the lip that lifts up. So he went back and measured the mountains around his crater and found one side's higher. He calculated which way the meteor was going to be coming, and he said, wow, it's probably right out here. He had enough money for one more hole. He went out, drilled down, kept hitting something that kept breaking his drill bits, and went broke. That's where the story stopped. That's the Barringer crater, so there may indeed be something down there. Some people think there's nothing down there. It probably got so hot coming in it broke apart, and it hit like a shotgun. A bunch of little pieces hit. So there really isn't a mother lode. Who knows, okay? But anyway, comets are constantly losing material. This is a fact. Nobody argues with this. And they have a life expectancy of less than 10,000 years. And you can't just keep losing and losing like comets are doing. I tell people it's like your checkbook, you know. You can't just keep losing and losing. If your outgo exceeds your income, your upkeep will be your downfall every time. You just can't keep spending money. But these comets are flying around with this life expectancy of less than 10,000 years. So I mentioned this in my seminars. And one scoffer named Madsen has a whole website devoted just to me. Madsen does. I think that he sent me his book. Several people have sent me his book. How Good Are Those Young Earth Proofs, or something like that. It's funny to read because just like students I had in high school, you know, they think because they said something, therefore they answered the question, you know. And the more they talk, it's pretty obvious the less they know about it. You probably did essay questions like that, right? Called a snow job, right? Just keep talking and talking. And you ought to read some of the arguments they give and just go slowly and think about what they're saying. Oftentimes, it's hilarious. Madsen said, here's his answer to my comet argument. Okay? He said, based on a study of the orbits of several long-period comets, the Dutch astronomer Jan Oort proposed, that means he guessed, he thought, he hoped, he prayed, that a great shell of comets existed at the remote frontiers of our solar system. Remote frontiers of our solar system. I'll show you what he means by that in a minute. Talk about remote. He said, better statistics in more recent years have supported the existence of the Oort Cloud and put it at a distance of 50,000 astronomical units. Now this would be a quiz question. What is an astronomical unit? That is the distance from the sun to the earth. If you're going to measure the distance in space, you need a bigger ruler. You don't want to say it's 474 zillion inches, you know, between these planets. You need a bigger unit of measure. So the distance from Earth to the sun is 93 million miles, roughly. That is called 1 astronomical unit. Now, we have how many planets in our solar system? 9. Does anybody know the acrostic to memorize the names of them? My very extravagant mother just sent us 90 parakeets, which would be dumb to do, but what it means is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Pluto is the farthest one out. It is 39 astronomical units away. You cannot see Pluto without an extremely good telescope. He is saying these comets are 50,000 astronomical units away. Now, tell me, do you think he's ever seen those things? I don't think so, right? Here's what they say about the comets, because you're going to have to face this, Eric, when you get out there speaking. Somebody's going to say this Oort Cloud is where they're coming from. Well, Earth to Sun is 1 astronomical unit. He's claiming this is 50,000 astronomical units away. What would the force of gravity be, considering the inverse square law? How much pull does the sun have on these comets? Real close to 0, right? Not much, right? Now, no one has ever seen the Oort Cloud, of course. This is all theoretical. Oort never saw the Oort Cloud. He made it up. He hoped it happened. He thought it might be there, but he does not know that for sure. Now, Oort proposed this in the 1950s. That's what Madsen said. In 1974, there was an article in Astrophysics and Space Science magazine, volume 31, that said, Oort proposed a cloud of comets surrounding the solar system based on mathematical errors. What that means is, there is no Oort cloud. It doesn't exist. But the rest of Madsen's answer is typical of the scoffers. He said, sorry, fellas, if you want, he's talking about me, if you want to use the comet argument, it's up to you to prove, beyond a reasonable doubt, that the Oort Cloud and other sources don't exist. Now think about what he's saying there. He's saying, if I want to use the comet argument as evidence the solar system is young, I have to prove the Oort Cloud doesn't exist. Well, you tell me, how could you prove the non-existence of anything? Why doesn't he prove the non-existence of God? You can't prove the non-existence of anything. And I tell folks, look, if he wants to use my tax dollars to teach all the kids in school the earth is billions of years old, it's up to him to prove it does exist. This is a typical tactic the scoffers use often. They try to shift the burden of proof on you. No, the burden of proof's on him. Here's the facts. We do have comets. They don't last long. 10,000 years seems to be a reasonable estimate for the maximum life expectancy of a short-period comet. We still have short-period comets. We know they don't last long. They certainly don't last forever. You can't just keep losing material. And the Bible teaches the earth is 6,000 years old. Now that all fits together just fine. So he's got the problem, not me. You will find, Eric, if you listen carefully when they make statements, when they ask you questions, the problem, the solution is in their question, the way they're asking it. Like, don't you believe in evolution? What do you mean by evolution? Well, things change. Oh, yeah, things change. Are the changes ever positive? Does the change ever add more genetic information? Never seen that. Does the change ever change it to a different kind of animal? We'll get into more of that later, of how they, when I got a debate tomorrow night, Saturday night in, wherever I'm going, Wisconsin. And if you listen to what they're saying carefully, you can pick out, after a little experience doing this, you can pick out exactly what to respond to them. But this guy is saying, it's our job to prove the Oort Cloud doesn't exist. This, of course, is ridiculous. This wouldn't hold up 2 seconds in a court of law. Some freshman lawyer would pick that one apart. Yes, sir?
If you think the Earth is 6,000 years old, now how old do you think the universe is? The same age?
I think the whole universe is 6,000 years. Because Exodus 20 in the Ten Commandments, God wrote on a rock with his own finger and said, in 6 days the Lord made heaven and earth, the sea, and all that in them is. Well, if he made it all in 6 days, that would include everything. Heaven, earth, everything. Made in 6 days. So, from Scripture, it's very certain that everything was made at the same time. There's no question there. Also, when we look at the evidence from space that we observe, there's no reason to say it's more than 6,000 years old. No reason to say it's billions of years old. The comets don't say that. The star galaxies don't say that. You know, they just all indicate, look, a few thousand years is all we need. Psalm chapter 19. The heavens, notice it's plural. We'll get into that later. Why is it plural? There is more than one heaven. There are 3 heavens mentioned in the Bible. The heavens declare the glory of God, and the firmament showeth his handiwork. The psalmist said, when I consider thy heavens, not if. Now, we've got a real problem in this generation because we've got a lot of kids that don't take time to consider the heavens. I tell them, you ought to shut off the TV, shut off the VCR once in a while, and go out and consider the heavens. I remember as a kid, we used to lay out in the yard and look at the clouds and try to see designs in the clouds, you know. Who can see the ships or whatever, you know. And my dad would teach us and Mom would teach us the different kinds of clouds. And what does this mean? You know, when you see the cirrus clouds, that means there's probably going to be a front coming through. Probably in a few days, you'll have a rain. You know, and you can actually, and Jesus talked about the Pharisees, how they were able to discern the face of the sky. You know, when it's red and lowering, you have a certain kind of weather. But we need to really take time to consider the heavens. He said, when I consider thy heavens. Psalm 39 said, while I was musing, the fire burned. The word muse is only used twice in the entire Bible. The other one is Psalm 143. He said, I muse on the work of thy hands. The word muse literally means to think. That'll be a quiz question. What does the word muse mean? Muse means to think. Now, English is a very interesting language. We have a word theist, which means a person who believes in God. Then you put the letter A in front, you get the opposite of. So an atheist is a person who claims to not believe in God. Just the letter A in front changes the meaning to mean the opposite of. The word muse means to think. The word amuse literally means to not think. That's the meaning of the word. They have entire parks where you can pay and go do that. How many have ever heard of those before? They're called amusement parks, right? We have a whole generation that wants to be amused, don't we? They don't want to muse. They don't know how to muse. They only know how to be amused. That's why if you watch the Hollywood movies, they get more violent, more explosions. Got to be something bigger, better than the last time. Just like drugs, you know, a person takes drugs or alcohol or anything like that. They want to get this thrill. Well, after a while, it takes more to get the same thrill. The person who drank 4 beers and got drunk, now he's got to drink 6, you know, and then he's got to drink 10, and pretty soon he's got to drink whiskey, and pretty soon nothing works. And the same with a person who chases thrills all their life. The thrill seekers, they're always looking for something bigger or better. They're being amused. They don't take time to muse. Just go outside and lay on the roof and look at the stars. We used to do that as kids. We'd go campouts, you know. Just go look at the stars for a while. I remember up in Colorado one time, we're up in the mountains. We laid out 3 o'clock in the morning. I woke up for some reason, couldn't sleep. I went out, laid on the picnic table, and saw 300 shooting stars in 1 hour. I still remember that, you know, it's 40 years later. It was awesome. I remember laying in Grandpa's driveway in the backyard in the middle of Arkansas, you know, and seeing the shooting stars going all over the place, scores of them. We need to take time to consider the heavens. Because when you do this, the psalmist said, when I consider thy heavens, the work of thy fingers, the moon and the stars which thou hast ordained, what is man that thou art mindful of him? See, a person who considers what God can do or what God has done is not impressed with what man can do. We see the bodybuilder, you know, he can lift 500 pounds. Well, you should see what God can do with 500 pounds. Right? And we've got an entire generation now that are sports crazy. They can rattle off the top 10 football teams and the top 10 baseball teams, but they couldn't name the 12 disciples. We have a problem, folks. We have an entire generation now that has not learned to muse. The story is told of the prince who was going to become the king when Dad died. The dad called him in. He said, son, I'm about to die. You will be the king. Son, I know you're only 20 years old. I'd like you to promise you'll do one thing for me, would you, son? He said, sure, Dad. Now, the boy was anxious to be king because he was going to party. Man, he's going to throw the biggest party, last the next 25 years. He said, son, I only ask you to do one thing for me. I'm asking you on my deathbed. He said, Father, whatever you say, I promise I'll do it. He said, son, I want you to take the first 30 minutes of every day and do nothing but think. He said, that's all you want? He said, yep, that's all I want. First 30 minutes, no entertainment, just think. He said, okay, Dad, no problem. Well, the first day he thought about all the parties he was going to throw and all the stuff he was going to do, you know, and he had a day all planned out, and he ran off into the day 30 minutes later. After several days, though, it started getting to him. He sat there thinking, you know, where's this lifestyle going to lead me? If I keep this up, where am I going to be in 5 years? What kind of a king am I anyway? What kind of example is this for my people? And after about a week, he finally got his life straightened out. And we've got an awful lot of kids that don't ever take time to think about where they're going. They're so busy being amused, they don't take time to muse. Since television came into prominence in America, it's gotten much worse. We have a lot of kids, honestly, I told my kids in school, what would happen if you couldn't have any electronic devices, no radio, no tape player, no TV, for 24 hours? It's like, oh, wow, I'd die, man. Well, you'd be surprised. You really wouldn't die. You might go through withdrawal for a few days, but you wouldn't die. We didn't have a television in our house for 11 years when my kids were growing up. They didn't have one. I wanted them to learn to muse. I like to see the little kids playing over here in the yard. Kids need to learn to imagine, to make up things. See the kids playing with the trucks and the cars. They have to have, developing an imagination is a vital part of growing up. People who study child development and child growth will tell you, kids that sit in front of the TV from the time they're 2 years old, something's wrong in the way they develop. They're not learning to think. They're learning to be entertained. It's got to affect them somehow. Go out and consider the heavens. According to the book, I think it's Ackerman's book. Is this the one? No, Donald DeYoung's book, Astronomy in the Bible, which I've got in my office. He said it's been estimated there are enough stars that every person on Earth could own 2 trillion of them. Just since part of the course is for Eric's edification here, if you want to learn how to count to big numbers, if we do this before, million is the number 1,000 with one set of zeros after it. Billion, Latin word bi for 2, has 2 sets of zeros. Mono, million, bi, billion, trillion would be the number 1,000 with 3 sets of zeros. Mono, bi, tri, what would come next? Quad. A quadrillion has 4 sets of zeros. Then, quint. If a woman has 5 babies, she has quintuplets. So a quintillion would be 5 sets of zeros. That's 15 plus the original 3, 18 zeros. Latin for 6 is sex. A sextillion is 6 sets of zeros. And then sept, S-E-P-T, for 7. Oct, for 8. Nov, N-O-V. Sept, oct, nov. Guess what's next? September, October, November, December. Used to be the 7th, 8th, 9th, and 10th month. And then Julius Caesar decided, I want a month named after me, so he made up July. And Augustus Caesar said, well, I want one for me too, so he made up August, and so that shifted everything down. So September, means 7, is the 9th month. Figure that out. October is the 10th month, but that's how they got the names. But just so you know, a trillion is a lot. If you started counting as fast as you could count, you probably couldn't count to a trillion in your lifetime. 2 trillion stars apiece. That's a lot of real estate we can have. And here people fight over just a few square feet down here, you know. There's plenty coming. Job chapter 12 said, speak to the earth, and it shall teach thee. What can the earth teach us? How old is the earth? The earth is like a big magnet. Now here's where the inverse square law would apply. The strength of 2 magnets, the force of attraction, is inversely proportional to the square of the distance between them. Which is why when you deal with electronics, computers, something like that, if you set a computer right on top of a TV, this could be bad because the TV has a giant magnet at the back that is used to direct the stream that's going across your screen. Stereo systems, any speakers have a big magnet in them. If you get a computer too close to a magnet, you create a problem. But if you double the distance, it's only 1/4 of the problem. So distance is the secret with magnets, or shielding, which they have to forget all that. Anyway, the Earth's magnetic field is getting weaker. Now, since a guy named Gauss, G-A-U-S or G-A-U-S-S, I taught science, not English, but Gauss began measuring the strength of the Earth's magnetic field. How strong is the magnetic field of the Earth? They've noticed since he started doing that, in the last 150 years, the Earth's magnetic field has lost 6% of its strength. If we have lost 6% of our strength in 150 years, the theory is that probably the decline in strength will follow what's called a logarithmic digression instead of a linear digression. Let me show you the difference here, what that means. If you go backwards in time, this would be linear, meaning a straight line. If it goes logarithmic, it may be like this. And without getting into all algebra and geometry and trigonometry behind this, these are called 2 different progressions. For instance, if you doubled the amount of money in the bank every year, or every day, or every month, or whatever. There's the story told about the guy who's told his friend, he said, I will give you $100,000 a day for 30 days. If you will give me a penny the first day and double it for 30 days. Double it every day for 30 days. If I made you offer 1 or offer 2, which one would you take? Offer 2. You get a lot more money. Now, for the first 20-some days, this guy racks up the dough, man. After about 20 or 22 or 24 days, somewhere in there, it starts to really eat him up, and all of a sudden he loses it all in a hurry. This would be a logarithmic or a geometric progression. Malthus was all upset because he thought that the population would increase geometrically and the food supply could only increase arithmetically or linear. Now, he's wrong, but that's what he thought. And that's what got Darwin all upset, saying, well, if there's more people born than can survive, then only the weakest should die off and the strongest should survive, and, you know, that's the way it's supposed to work. That's all led to Darwin's thinking. So, the Earth's magnetic field, we've only got a short piece of data to measure. You got a series of points for 150 years. Based on that short section of information, you have to decide, is it going to be a geometric or a linear? Either way, it creates a problem for the evolutionist. It creates more of a problem if it's geometric, but even if it's just a linear digression or progression back into time, it still creates a problem. The Thomas G. Barnes at University of Texas, El Paso, taught physics there for years. He said that the Earth's magnetic field is declining at such a rate that it cannot be more than 25,000 years old. He said if you go back in time, actually I've kind of got it backwards here to where normally the way you'd look at a graph, it's declining. The strength is declining. This has been measured, let's call this the year 2000, and this the year 1850. As the magnetic field gets stronger and stronger and stronger, this would indicate a hotter center to the Earth, or more movement. If you go back in time, how far back can you go before there's too much heat? And he calculated at 25,000 years ago is the limit where life could not exist on Earth. Now, there is no question in anybody's mind that the Earth's magnetic field is getting weaker. That is never questioned by the atheists or evolutionists or anybody. They all agree it's getting weaker. How do you handle this data is what the problem is. The creationist says, well, this proves the Earth is young. The evolutionist says, no, this is just part of a cycle. It's declining now, but it's reversed through the years. Remember we talked about magnetic reversals? There are no magnetic reversals at the bottom of the ocean floor. But they say, well, the Earth's magnetic field is reversing. This idea of continental drift and Earth's magnetic field reversing, flipping, is all, I think, a very desperate attempt to salvage the billions of years they need for their theory to look reasonable. When the simple fact is, the Earth is not billions of years old. Okay, so the magnetic field is declining, and this indicates less than billions of years, certainly. It indicates it cannot be billions of years old, and this indicates carbon dating cannot work. Now, here's why. The Earth's magnetic field, as it declines, it allows more radiation to get in. One of the protective barriers we have around the Earth is our magnetic field. Hang on here. There we go. The magnetic field protects us from radiation, along with several other things the atmosphere has. But if the magnetic field is getting weaker, more radiation gets in. And it's that same radiation that makes carbon-14. So if the magnetic field was stronger in the past, you would have less carbon-14. So any plants that were breathing this carbon-14, if we're going to check them against today's standard, we're automatically going to get a wrong number because they had less. So the magnetic field is one of the factors affecting the amount of carbon-14 in the atmosphere. Textbooks are going to say the Earth's magnetic field has reversed. This is a typical textbook saying there are areas of reversed polarity. Now, the reason they teach this to the kids, even though it's not true, probably the author of the textbook does not know that it's not true. He thinks the Earth's magnetic field has reversed. Let me explain what happened. They dragged a machine across the bottom of the ocean, and plus they did drilling to drill down, bring up samples of rock, and see how strong is the magnetic field in this rock. When you get into iron or magnetite or metals, rock that will store a magnetic field, they can check how strong is the magnet. Measure it with so many Gauss or whatever units they use for measuring the Earth's magnetic field. They find out there are areas of stronger and weaker magnetism. And so what they did, they graphed out as they moved across the bottom of the ocean. They said, oh, here's an area, here's stronger here. Now it's weaker, weaker. Oh, stronger, stronger, weaker, weaker. And it made a wave, a sine wave they call it. It goes, curves up and down. It was weaker and stronger and weaker and stronger and weaker and stronger. Some guy drew a line through the middle of the sine wave and said, everything below this line is a reversal. And right there's where the problem is. It wasn't a reversal, it was just weaker. If we lined up everybody in the world and found an average height, we'd have short people, tall people, short people, tall people, short people. We draw a line through the middle, find the average. Is everybody below the line underground, or are they just shorter? They're not underground, are they? They're just shorter than the average, that's all. And everything below the line was just less than the average intensity. It was not a reversal. Now, how they get by with this, I don't know. But I think nobody ever checked out the truth is what happened. There are no magnetic reversals on the ocean floor. Only areas of stronger and weaker magnetism. Okay, suppose you can prove there are no magnetic reversals, only weaker areas of magnetism. Now we need to come up with an explanation for why is one area weaker than the others, and we've got that on video number 6. We'll get to that. But what does this do to the evolutionist? You just took away the idea that there are reversals. So now you go back to your original problem. The Earth's magnetic field is getting weaker. So how old is the Earth? If he wants to believe it's billions of years old, now he's going against some clear scientific evidence. It can't be billions of years old. That's for sure. Okay, the Earth is slowing down. Now, scoffers really attack this, what I'm about to give you here, this proof of a young Earth. But in 1990, the newspaper article here in Pensacola said, we're going to have to give 1990 one last tick. On New Year's Eve, they added an extra second into the clock. This article says, regular clocks use days as a measure, which are growing longer by 1,000th of a second or more daily as Earth's rotation slows. The Earth is slowing down. This is Astronomy Magazine, 1992. They said Earth's rotation is slowing down. June will be 1 second longer than normal because we're going to have a leap second. There's actually, it's called the International Earth Rotation Service. One of those government jobs. Somebody needed, somebody's uncle needed a job, so they started a new program to keep track of it. But the Earth is slowing down. Since they started keeping track of this, I believe 1973 is the first leap second. They've been adding a second to the clock about every year or year and a half. This International Earth Rotation Service decides when to do it. They try to do it in January or June. Now, do they wait 12 months or 18 months? That varies. What would slow the Earth down? The Earth is spinning in a vacuum. There's nothing in space. Why would it slow down? There are at least 3 factors that slow it down. Who can tell me what any of them are? Gravity from the sun, I don't... Well, because of the inverse square law, gravity from the sun is pulling a little bit stronger on the close side of the Earth than it is on the far side of the Earth. There's an 8,000-mile difference there. So there's a little more pull on the near side than there is on the far side. I don't know if it's even measurable if the gravity from the sun would slow it down. The 3 factors, maybe a good bonus question at least, maybe not a quiz question. But one is the Earth is spinning, but the inside is liquid. So there's going to be a little bit of internal friction by the liquids moving around inside. If you were spinning a basketball that was full of water, there'd be some friction inside with this liquid versus this hard surface. And the crust of the Earth is not the same thickness at all places. It's thicker under the continents and very thin under the oceans. So you have a liquid moving a little bit inside of a ball that is not smooth inside, because the crust of the Earth is not consistently uniform and smooth inside. The liquid down inside, when it comes out, we call it magma. Volcanoes put out the lava. That's magma, the liquid rock coming out. The place where it changes from solid to liquid, nobody's ever seen this. This is theoretical. But they did try to find it, actually. They were going to drill down and try to find where does it change from solid to liquid. Some scientist, I forget what country he's from, he had a strange name, Moho Ravisic was his name. So in honor of Moho Ravisic, they named this place where it changes from solid to liquid, they named that area the Moho Ravisic Discontinuity. For short, they call it the Moho, okay? M-O-H-O. They spent a lot of money trying to drill down to find the Moho. Where does it change? The way that they know it changes from solid to liquid is pretty surprising and pretty ingenious the way they do this. When an earthquake is happening in San Francisco, it shakes the ground. They can have a machine here in Pensacola that can sense the ground shaking that far away. I mean, if I stomp on the floor here, can you feel it where you are? Well, if I drop a 20,000-pound weight on the floor here, they'll feel it down the block, right? As the earth shakes, you can feel it at different parts. Now, the movement travels different through solid than it does through liquid. So they noticed if you have an earthquake in San Francisco, in Tokyo, their machines move. A few seconds later, they move again. It's not a different earthquake. It's the same earthquake, but they travel through the crust of the earth one speed and through the liquid at a different speed. Yeah, they're called S and P waves, I believe. You can study that in earth science about the different. Plus, they can discover, as the earth shakes, if it's shaking in San Francisco, on the opposite side of the world, which would be someplace near Australia, I would guess, they'll notice they don't get the right kind of S and P waves. It's like there's a shadow, and that's how they've determined the center of the earth has different parts. It has the mantle and then the core. They said there's something solid in the core, and I don't know how much is proven, but it is pretty reasonable that there seems to be a shadow to the S and P waves, or whichever is which, as they go through the earth, indicating there's something even more solid inside called the core of the earth.
Could it mean that there's something solid, or that could possibly be hollow?
Or hollow, yeah.
And it's spinning and it throws it.
Yeah, if it's hollow, brings up another interesting set of theories you could come up with on that. Who knows? But anyway, the earthquakes, with these, they can tell what the crust of the earth is like. So one of the factors that is slowing the earth down is the liquid center. The other factor is the liquid surface. If you ever been standing out in the ocean and a wave hits you, knock you down, right? Well, those waves are hitting the beach all the time, aren't they? As the tide comes up, the water is pushing against the land. That's going to eventually slow it down. If you were spinning a basketball that had water all over the surface, the friction of the water dragging on the surface would slow your ball down faster. So you have internal friction. You also have external friction. This is from the tides. It's actually, there's a name for it. It's called tidal braking. It's like putting the brakes on. The tides have a very minimal effect, but they do have an effect. The tides are slowing the earth. The third factor, surprisingly enough, because the earth is spinning under a hot sun, the sun heats up the air, causes it to expand. As it expands, it rises. As it rises, cold air goes in the bottom. So you get hot air rising, cold air falling, rushing in, and you get wind currents. The earth has obvious wind currents, okay? The spin of the earth, combined with the heating and cooling of the earth, causes what is called the Coriolis effect. Some guy named Coriolis made it up, I guess. But the wind blowing against the mountains has a very slight slowing effect. So the wind patterns tend to slow the earth a little bit. The tides slow it, and the internal friction. Those are at least three. There may be more factors, but those are three that I know of. The bottom line is the earth is slowing down, and it's measurable. These are the dates when they've added a leap second to the clock. From 1973 up to 1996 I have here, for when they added a leap second, because the earth is slowing down. Now, if you go backwards in time, obviously the earth used to be going faster. I wouldn't put a date on this one and say if you went back, 1.4 billion years, you couldn't live here. Because then as soon as you put some kind of date, some skeptic's going to figure it out and say, no, it's 1.7 billion, see, you're wrong. And he's going to miss the whole point. The point is it can't be billions of years old. So what I say in my young earth proofs now is, look, the earth is slowing down. This everybody agrees with. This means it used to be going faster, obviously. We know of no factor that's going to add energy to the Earth. If a meteor hits the Earth that's spinning, there's a possibility it'll speed it up a little bit. But just random chance is going to say an equal number are going to hit it on the wrong side to slow it down. I mean, odds are 50-50, right? So you can't count meteors here as anything to get excited about. So if the Earth is slowing down, there's the Coriolis effect is the name of it there. That's what causes the wind patterns. And that's an interesting study which you should get into in earth science about why do we have prevailing winds. Here in Pensacola, it nearly always comes from the northwest. Other parts of the world, the wind almost always comes from a different direction. Depends on how far you're above the equator and all that stuff. So if the Earth were billions of years old, it used to be going faster. And I make a joke out of it at this point and say, well, if you think the dinosaurs lived 200 million years ago, man, I know what happened to them. They'd have been thrown off the Earth. Now, the truth of the matter is, at 200 million years ago, it probably wouldn't be real sufficient or real significant as far as the effect. In 6,000 years, it'll make a few minutes or maybe 15 minutes a day difference. You go back a few billion years, it starts to make a real difference. Now, several planets today are spinning awful fast. I believe it's Jupiter spins every 10 hours. That's a giant planet, for one thing, and it's spinning every 10 hours. Venus spins once every 443 days, or something like that. It's real slowly spinning. So different planets have different spins, and who cares? You can learn all that stuff if you like. But the Earth is slowing down in its spin for at least 3 factors, which means obviously it used to be going faster. This puts a time limit. For one thing, the textbooks are going to tell the kids the Earth is billions of years old. The Earth formed, according to them, 4.6 billion years ago. Now, at that time, the Earth would have been spinning an awful lot faster. If the Earth was spinning, say, let's just say it's spinning 20 times faster, the Earth is almost a perfect ball. What happens to a ball when you spin it real fast? Flattens out, becomes like a frisbee, right? So if the Earth was cooling down 4.6 billion years ago and spinning lots faster, it wouldn't be round. The crust would have hardened in an egg shape, frisbee. We wouldn't have a near perfect ball. The Earth is flattened right now. The poles are pulled in, I think it's 20 miles. It's about 20 miles wider at the equator than it is at the poles because of its spin. It's pretty heavy, you know, and just the centrifugal force going around at 1,000 miles an hour, it's pulling it out a little bit. So the Earth is spinning. Okay, the Earth is spinning is a scientific fact. How fast it was going a billion years ago, I don't know, but it does put some kind of time limit. And evolutionists don't like time limits at all. They want to have billions and billions of years. Another factor here. The Sahara Desert is the largest desert in the world. The wind almost always blows the same way because of the Coriolis effect. It happens to be in an area where the wind blows the same direction most of the time. The hot air comes off the desert and kills the trees at the edge, and that area becomes desert. The process is called desertification. That'll be a good quiz question. The process by which deserts grow. What happens is, once the area becomes desert, all the minerals leach out of the ground, and nothing will grow there again. You take pure, hot, baked sand and plant some seeds in it, there's nothing there for them to grow on. And so the soil actually gets sterilized. Nothing will grow. Sahara Desert is 1,300 miles north to south. This textbook tells the kids, notice the picture here, past Sahara Desert was pretty small, wasn't it? The yellow part. Then the pink part is the present. Possible future extension. People living right on the edge of the Sahara Desert are making the problem worse because they want to build a house or have a fire to cook their food. There's only a few trees anyway, so they cut them down. And now there's no trees. You get a good rainstorm, what happens to your soil? Washes away. Now you can't plant your crops because your topsoil's gone. So they move on further south. Because of the desertification process and because of people and their poor farming practice, the Sahara Desert right now is growing 4 miles a year. At 4 miles in a year, at 100 years, that's a problem. What used to be good, beautiful farmland is now desert in a hurry. What are all these people going to do? Keep moving. Where? Onto somebody else's property. Going to create a problem, right? Regardless of the human suffering and tragedy going on over there, and it is a tragedy, because of this process, this desert is growing. But even if no people lived there, the desert would still grow because of the hot air killing the trees and grass at the edge, and the soil gets sterilized. They did quite a study on this and said the Sahara Desert is about 4,000 years old. Actually, now with satellites, they can go up and fly over with the satellites and look down and see where old rivers used to be. Riverbeds all over the Sahara. Used to be a lush tropical forest. Sahara Desert's about 4,000 years old. Now that brings up an interesting question. If the Earth is billions of years old, why don't we have a bigger desert someplace? Why do you think the largest desert in the world is less than 4,000 years old? You have a theory about that, Dan? Yeah, me too. You see, about 6,000 years ago, God made everything. 4,400 years ago, there was a flood. In this flood, everything drowned, of course, and it's pretty hard to have a desert under a flood. And so the biggest desert in the world should be less than 4,400 years old, if the Bible is correct. Oh, and it is. Well, what do you know? So here we have an interesting correlation that the Bible date is correct. Roughly 4,400 years ago, a worldwide flood. When they drill down into the ground, they hit oil. The oil's under pressure up to, I don't know, I've not heard of any exceeding this, but up to 20,000 pounds per square inch of pressure. That oil wants out of there. How many have ever seen the movies where they drill down and hit a gusher? The oil comes squirting up out of the ground, okay? Not all oil wells are that way, believe me, but some are. Incredible pressure. When we lived in Texas, we had a lot of guys that worked in our church that worked in the oil field. And being a science teacher, I was always curious about the oil, you know, and how do they do this? And I would go out and visit the oil wells and, you know, watch them drill this stuff. They drill down about 1,000 feet, a big 12-inch hole. That's quite a post hole digger, by the way, they've got for that. They dig down 1,000 feet. Then they put a special donut down there called a blowout preventer. And they run wires up to the top to a switch. Then they go and they drill through the middle of their blowout preventer. They drill a 4 or 6-inch hole the rest of the way down. If they hit a high pressure pocket, the switch automatically trips to close it off. Because in the early days, they would drill down for gas or oil. They hit one of these high pressure pockets, and it comes shooting up out of the ground so hard, it eats the side of the hole away, and the hole gets bigger and bigger and bigger from all this oil squirting up, and pretty soon everything falls in the hole. People, buildings, tractors, everything. There was one in Texas, East Texas, I believe, where it ate up an entire acre, collapsed. Killed a bunch of people. Everything just swallowed up into the ground. It wasted a lot of oil, too. Blows all over the place. So now they prevent that with what's called a blowout preventer. Who cares, right? The fact is, oil wells often have incredible pressure down there. Now, the guys who deal with this have to have special tubing, special valves, special equipment. They're ready to handle incredible pressure. The scientists who studied the rocks on top of the oil say this rock can't handle the pressure for more than about 10,000 years. The pressure should have leaked off. What would eventually happen is the rock's going to crack. When I was in Texas, in the middle of oil patch in Longview, Texas, we had guys, I'd go soul winning, and they would say, oh, I do frack jobs for a living. So you do what? He said, yeah. We drill down, we pump the oil out of the ground. Now, you got to figure, way down there, it's like a big sponge, only hard rock sponge, a sandstone sponge. You pump out the oil, it soaks into the hole, you pump out some more, and you got to wait till more oil soaks in. Oil's not in any hurry to get to the hole, just gravity fed, okay, or under pressure. But after a few years, you've pumped out an area about as far as you can get. Now your oil well quits pumping. Nothing down there to pump anymore. So they pull the pump out, pull the well out, pull the pipe out. They pour in a bunch of liquid nitrogen, and then quick pour a bunch of concrete in the hole to fill the hole in, maybe 100 feet of solid concrete. The concrete hardens, the nitrogen is hot, turns to gas, expands, and it creates so much pressure, it cracks the rock underground. And cracks go shooting out for hundreds of yards in all directions. It's an underground explosion is what it is. And they're fracturing the ground out, you know, from here to PCA. Now the oil over there has got a crack to flow through, so it flows into your hole, and you can start pumping it again. Of course, now you got the problem. You've got your concrete plug. You've got to drill that out. So it's a real expensive process, but that you can study all that if you'd like to get into oil production. But the fact is, we do have pressure. It doesn't last long. So two obvious questions should come up. Why is there oil in the ground? Where did it come from? And why does it still have pressure? Nearly all scientists agree that oil comes from organisms, living organisms, that are squeezed and heated. Under pressure and heat, you can convert a ton of garbage to oil in a few minutes. There's a good article in Creation magazine, Creation ex nihilo. If you get the 1990 edition, I believe is where it is. Also, Impact article number 155 are some good ones to read if you want to study. And Eric, you should do this. Definitely read up on oil formation. Scientists can take a ton of garbage and squeeze it into oil in the laboratory in about 20 minutes. They did a test where they took some organic material. Now, the word organic means something that used to be alive. Plants, animals, okay, is organic. Oil is, almost everybody agrees, comes from organic material, plant or animal or human. Under pressure and heat will change to oil. Hitler, it is reported, some of the Jews that were killed, he took the bodies and had them baked to produce oil for his tanks. I don't know, I can't verify the story, but I've had several folks tell me, yes, it's true, that they didn't do that with all of it, but they did it with some to see if it would work. They found it was too expensive to do. Okay, the pressure and heat produces oil. So I don't know what the numbers are, but let's say you can make a barrel of oil for $1,000. You take a ton of garbage, squeeze it, heat it, turns to oil. One person said to me the other day, why don't they make oil that way, you know, cut the price of gas? I said, well, you can drill and pump the oil out of the ground for about 20 bucks a barrel. If they start producing it for $1,000 a barrel, your gas is going to cost, you know, $1,000 a gallon. You better leave it alone, okay? It's still cheaper to drill it. The fact is it could be done. It just isn't practical to do that. So oil can form quickly. So the obvious question would be, how did the oil get way down there in the ground? 3, 4, 5, 6,000 feet down, you know, 2 miles down. All over East Texas, they drill down 3,800 feet, I believe is the number, and they get into the seam where all the oil is. They can pretty well count on it. You know, we drill down 3,800 feet, you're probably going to hit oil. In Kilgore, Texas, remember the oil museum? They had 28 oil wells on 1 acre, the size of our property. They called it the world's richest acre. They pumped it for years and finally pumped it dry. Today it's just a museum. Okay, there's no more oil, not enough oil down there to make it worth going after. But Sinclair Oil Company has the dinosaur as their logo because they say the dinosaurs turned to oil. And they're probably right. And they, you know, these guys drill for oil all the time. Sinclair is still a very valid company, mostly out west. You don't see them much here, but in Arkansas there are Sinclair gas stations, and all over out west, Sinclair Oil Company. The article, How Fast Can Oil Form? Creation ex nihilo, volume 12, number 2, page 30, talks about that. I've got this sign in my office from Sinclair saying dinosaurs have been mellowed for 80 million years. Now, slow down a minute. Yes, the dinosaurs probably turned to oil, but it wasn't 80 million years ago. I think that all happened at the time of the flood. Very simple. You got a world full of people, full of animals, full of plants. Now you get a flood that destroys everything. The flood lasts for a year. At the same time as the flood's going on, you got volcanoes blasting ash and lava up, and you got all kinds of bad things happening to the earth. You're going to get all these carcasses buried under thousands of feet of mud, sediment, debris, rocks, lava, ash. The pressure, how much does a cubic foot of water weigh? A gallon is 8 pounds. 62 pounds, 64, 62 pounds, okay, depending on what kind of water it is, salt water, etc. If you lay it on the ground, and I put a box 1 cubic foot on top of your stomach and filled it full of water, 62 pounds. Let's stack up 10 of those boxes. 10 feet of water puts 620 pounds of pressure per square foot. Let's stack up 100 of them. 6,200 pounds of pressure per square foot, right?
Now, wouldn't it be different if you were surrounded by water?
If you're down in the water, yes, it's different. However, your eardrum is a little piece of skin stretched across an air pocket inside. That's why when you go down in deep water, the air pressure pushes on your eardrum and stretches it, pushing it in. And you have to go slowly so your air inside your head, in your eustachian tube, can equalize the pressure. That's why when you go up and down the mountains, you have to hold your nose and blow, to pop your ears, to equalize the pressure. Scuba diving, you have that, especially if you have sinus trouble, you have trouble scuba diving because, your ears will never equalize. Who cares, right? Rock weighs more than water, right? Let's say a cubic foot of rock weighs 100 pounds. It's probably a lot more than that, but let's just pick a number. 100 pounds per cubic foot. Let's stack it up 3,000 feet deep. How much pressure is it putting on 1 square foot 3,000 feet down? Is that 300,000 pounds per square foot? That's a lot of pressure. That's for 3,000 feet. Oil is anywhere from 3,000 to 10,000 feet down. So the pressure of the rock above is enormous, plenty, and since it's just pressure, pressure produces heat. So you got exactly what you need, pressure and heat, to convert whatever was buried to oil. If they can do it in the laboratory in 20 minutes, it certainly can change in 4,400 years from buried carcasses into oil. So that's where the oil came from. I believe the oil came from the people and animals that drowned in the flood. So I tell them when you go to the gas station, you can say, "Bye, Grandpa, you should have listened to Noah. He told you it was going to rain." And that's probably what happened to the people that did not listen to the Lord. One more thought here. Young Earth, and we'll take a quit for the evening. In Denver, Colorado, I was preaching out there, and some guys came to the meeting. They said, "Now, Mr. Hovind, we know you teach the Earth is only 6,000 years old. We would like to prove to you that you're wrong." I get this just about every week. You probably will too, right? These guys worked at the Denver National Ice Core Laboratory. Denver National Ice Core Laboratory. It is a section of the Federal Center in Denver, Colorado. What you're seeing here is a picture of a giant freezer. This freezer is enormous. The guys who brought me into this freezer, it's 36 below zero in there all the time. Taxpayers are paying the electric bill, so, set it where you're comfortable. The freezer is enormous. These were the guys that go to Greenland and drill holes through the ice. They also go to the South Pole and drill holes. The Russians are doing this too. They take these, it's called a coring machine. Here's a picture of one here. It's like a pipe. It drills down, maybe a 4-inch pipe. It drills down just the outside. So the center part is not disturbed. It's called a coring machine. I asked them, I said, "Now, when you're drilling a pipe down into the ground and you pick it up, doesn't the piece fall out?" They said, "Oh, no." They showed me the thing, how they do it, the drilling machine. It's got little flaps in there down near the bottom. When they stop turning, as soon as they start to lift up, these flaps come in and catch. So they drill about a 6-foot section at a time. They drill down. As soon as they start to lift it, it snags the bottom and breaks it off. So they pull up a 6-foot piece of ice about this big, slide it into a tube and mark it. This is number, 813 or whatever it was. Then they can go back to the laboratory and put them in order and reassemble it. So they have a huge, long core of, just as if they laid it out from drilling down. The deepest hole they ever drilled is 10,000 feet through this ice with this coring machine. They actually set up a big building over the top to stay warm while they're doing all this work, and they may live there for 2 months while they're drilling a hole, just so they can have some more ice in Denver. Just what they need. But this newspaper article said, in Lakewood, Colorado, a Denver suburb, Associated Press, 10 ice core samples yanked from a remote Antarctic glacier are resting in a giant freezer here waiting to be tested. What do they want the ice out of the Greenland and South Pole for? When they drill down, here's the coring machine. You can see the teeth at the end, how it kind of grips it when it starts to pull it up. I drew these lines on here because you can't see it at this angle, but there are dark and light lines, which I'll show you in a minute. The guys took me in the freezer and they showed me these lines. And here's a photograph of one. You can see the dark and light lines. They said, "Now, Mr. Hovind, up in Greenland, it doesn't snow much, and it's really cold in the winter. In the summer, the snow melts just a little, and you get a layer of water on top. Then it refreezes in the winter and makes a clear layer of ice." Now, clear ice on this picture shows up as a dark line. If it never gets a chance to melt, the snow is going to pack or press down and make a white layer of ice. So they said what these layers represent is summer and winter, summer, winter, summer, winter, summer, winter. Well, that's not true, as we'll see. This rest of this newspaper article said, in Greenland and Antarctica, where the weather is consistently dry and very cold, the glaciers are miles thick, but the annual rings are very thin. Summer, winter. Now here's where the problem is right here. The deepest cores can measure over 10,000 feet. Cores from Greenland drilled since 1990 show the northern climate was erratic 135,000 years ago. All they do, you count back 135,000 rings and assume we can look at the weather patterns. Did they get more snow or less snow in Greenland? Well, what's the obvious assumption in all of this? That the rings are annual. Just because you got a clear line and a white line, packed snow and melted snow, doesn't mean it's annual, does it? We know that it's not. This is The Lost Squadron. I've got the book and the video if you want to watch it in my office. Stop by after class and I'll let you take it home and watch it. I tell you what, if you want to check out any of my stuff, Heidi, if you can kind of keep track of who does it, so we can be sure to get it back. Because I know how people are. They borrow and never return, you know. But I'll let you take my video home and you can watch about The Lost Squadron. It's very fascinating. Did you go with me, Eric, when we saw the plane? If you ever get up to Knoxville, just go north another hour and a half into Middleborough, Kentucky. If you get up in that region, it's worth going to see. Get your picture taken beside it. Okay. Some airplanes ran out of gas during World War II. So they turned around and were going to land in Greenland. And the first one came in and flipped over. He hit a crack in the ice. He was fine. The guy got out, radioed back to the rest of them. He said, leave your landing gear up. Just come in and belly land. You know, because if you put your wheels down, you're going to flip it over. So the rest of them, they ran out of gas. They've left their wheels up and slid in on the ice, and everybody's fine. I think one guy broke his arm or something, but I don't remember. It's all on the video. Anyway, these airplanes landed in Greenland. The guys waited there for like 4, 5, 6, or maybe 9 days until somebody could rescue them. And it's a long story of how they almost froze to death. Anyway, the Eskimos came in there with dog sleds, got them, and took them out. Everybody's fine. They left the airplanes, of course. For one thing, coming in with your wheels up is not good on your plane. Your props hit the ice. Sudden stop on one of those motors is death to the motor. It destroys, bends the crankshaft and everything else. Who cares? Anyway, they left the airplanes. Well, some rich guy from Kentucky decided, we've got brand new World War II airplanes sitting up there. Vintage aircraft. He's got plenty of money, so he sent some guys up there to dig the air to get the airplanes. At first, they thought they might just brush the snow off the wings and, you know, gas them up, rebuild the motors maybe, and fly them home. They finally found them by using ground-penetrating radar. So much ice had accumulated over the top of the plane. The planes were under 263 feet of ice in 48 years. They were P-38s and a couple of regular other fighters and a bomber, I forget what it was, but they especially wanted to get a P-38 because there's only a few in the world still flying from World War II that people have kept up. They've got a website for this called thelostsquadron.com if you want to look up information on these airplanes that landed in Greenland. They melted holes down. They built this machine up there. They called it a gopher. They took copper tubing and wrapped it around and around and around and around, made a big, huge ring of copper tubing, and pumped hot water through it. Kind of a cone shape of copper tubing. And they set this on the ice, and they pump hot water through it. And, of course, it slowly melts its way down. As it melts down, they pump the water off, and you end up with a nice, clean, dry hole. You get down about 60 feet or something, and they run into a layer of, basically, it's all water. It's still in ice, but it's water's coming in pretty quickly. And so they have to keep the pumps running continuously, pumping water out. They've got some pretty heavy-duty pumps, too, because they're pumping up 263 feet. Takes a real heavy-duty pump. Anyway, they melted these holes down, took the airplanes apart, took one of them apart, and brought the pieces up through the hole. Imagine going down in a 4-foot hole, 263 feet, 26-story building. That'd be scary. Claustrophobia city. They were down in the planes were in the ice for 48 years, 263 feet. You divide it out, that's 5.5 feet a year. 10,000 feet is the deepest hole they ever drilled. Divide that by 5.5 feet per year, and you get 1,824 years. Now, the newspaper article said those 10,000 feet represented 135,000 years. Where's the flaw in their logic here? They thought those were annual rings, and they weren't. Now, some have said, if you lay a weight on top of a piece of ice, it'll sink right through the ice. If you put, lay a big block of ice on a table, and you put a weight on each side and a string going over the top, it'll cut the block right in half. How many have heard of that experiment before? Lay a penny on top of a block of ice, it'll sink down through and be frozen on top. It'll end up in the middle of the block of ice, frozen completely around it. This is true. However, that only works at room temperature. Some have said those airplanes probably sank in the ice. They melted down over the years just because of the weight of the airplane. Well, that's not true. Because, for one thing, airplanes are always built nose heavy. The front of the plane is heavier than the back. Why would they do that way? What if your engines quit running? You want to glide in head first or tail first? Well, head first, right? So airplanes are always built with over 50% of the weight in the front. If those planes were sinking down because of gravity, they would be crooked. They're not. They're flat. Secondly, things don't sink through the ice based on their own gravity if everything is uniformly cold. That experiment with a penny through the ice will only work at room temperature. And the planes were not crooked. They were flat. Bob Cardin is the guy who dug out the airplane. He was in charge of the project. There's his phone number right there. I said, Bob, when you went down to get the airplanes, did you notice rings above the airplanes? He said, well, yeah. You can see them on the picture here. See the dark and light lines? I said, how many lines were there, Bob? He said, oh, we never counted them, but there were many hundreds of them. Now, how do you get many hundreds of annual rings in 48 years? You don't, do you? Those aren't annual rings. That's not summer, winter, summer, winter. It's warm, cold, warm, cold, warm, cold. You can get 20 of those in 1 week in Minnesota, can't you? Sure you can. Those are not annual rings. Now, last February of '98, Scientific American, a major science magazine, an author published an article about the rings in Greenland, and he still called them annual rings. This is 8 years after they proved they weren't. Now, we have a problem here. Either the author is ignorant of the truth, or he's lying. He's certainly not right. So hopefully he's just ignorant, because ignorance can be fixed. Okay? Stupid is forever, but ignorance can be fixed. If he's just ignorant, we can deal with that. If he's stupid, I'm sorry, we can't help you. Those are not annual rings. This picture a guy sent me just a few weeks ago. He said, Mr. Hovind, I saw your tape. He said, I live in Alaska. He said, we had a snowstorm one night. In 8 hours, the snow piled up all over my car. He said, as I was cutting the snow in blocks to take it off my car, I noticed there's lines in it. He said, I got 15 layers of snow on my car in 8 hours. Those aren't annual rings. The Inuit Indians, he said, have 42 or 43 different words for snow. There's soft snow, hard snow, crystalline snow, granular snow, slippery snow. Different words. And so in one snowstorm, you can get all sorts of layers in a hurry. So don't let anybody tell you that the Greenland proves the Earth is millions of years old. But invariably, when you do a debate or when you get into an email discussion with somebody, they will say, the varves in the ice, they call it a varve, V-A-R-V-E, the varves in the ice prove the Earth is more than 6,000 years old. And they probably really believe what they're saying, but they're wrong. Because they assume those are annual rings. We'll get into varves later, V-A-R-V-E-S, when they talk about the varves in Wyoming, the Green River Formation. We'll get into that later on. Okay, next week we'll cover some more evidence the Earth is not millions of years old. Thank you so much for joining us.